Yes, good afternoon. Am I audible?
Yes, sir. Good afternoon, sir.
Yeah, good afternoon. So today is the lab tutorial session. So I will understand the program, fifth program. In fifth program, there are two, 5A and 5B. 5A is evaluating a given postfix expression. Okay, we'll understand that, and then the 5B is tar of an eye problem, the program which is based on what I explained yesterday. Okay. Now I'll show you the syllabus. So question I'll show you first. Fifth lab question. I'm sharing my screen now. Yeah, I hope all of you can see my screen.
Yes, sir.
Yeah. See, design, develop and implement a program in C for the following stack applications. First one is evaluation of suffix expression with single digit operands and operators plus minus, into, divide, modulus and exponentiation. So these are the operators which you have to use, and single digit operands. So because you cannot use the multi digit operands. Okay. So if I write 2 5 plus, it is 2 plus 5, it gets evaluated as 2 plus 5, it is not considered as 25. Okay. And 5B is solving tower of an eye problem with n disks. Okay. So that is what is 5. Okay. So copy this question, fifth question, and then we'll go to the program. Copy this.
We are writing.
Yeah. Just copy this 5A. 5B will copy later. So not this class, next lab.
Done, sir.
Okay. I'm opening the program now. So this is the program. Okay. Again, this we are solving using the stacks. Okay. So we have stdio.h included, and then lib.h, ctype.h, math.h is also used here, and then maximum size of the stack we are taking it as 60. Okay, the character array, because you have to read the postfix expression. No, the maximum number of character that can be there in the postfix expression which you are reading is 60. And then these are the function prototypes. So we have push, because you know the logic already, how to evaluate the given postfix expression. You have to start scanning the given postfix expression from left to right. So when you scan, if the scanned token is an operand, you'll be pushing it onto the stack. If the scanned token is an operator, you'll pop 2 elements from the stack. So the first element will be popped from the stack and assigned to operand 2, and the second element is popped from the stack and assigned to operand 1. And then we perform the operation and we push the result back to the stack, and we repeat this process until we reach the end of the postfix expression. Okay, so this is these are the function prototypes. So I have push, because you know push is required, because whenever you encounter an operand, you got to push it onto the stack. And similarly, pop is required, because whenever you encounter an operator, you got to pop 2 elements from the stack. And then evaluation is another function which we are calling, which is going to evaluate the expression. And another function what we have is operator. Okay, so for push you are passing the stack, and then the top, and then the element to be pushed. And for pop, again the stack and then the top, only 2 things. And eval, so what you are passing is the character array itself. And then operator, so we have the character is the operator, this is storing the operator. So this is first operand and this is second operand. So what this does, so on these 2 operands it will perform the operation. We'll understand all this function later. And next, inside the main, so we have this character expr of max. I'm declaring a character array of size max 60. So you can enter a postfix expression up to length 60. And then you're saying enter the postfix expression, and we are reading the postfix expression. Since it's a character array, so we have used %s and we are reading it to expr. And then I'm printing the original postfix expression. So as it is, I'm printing it. And then, so I'm calling the function eval. Okay, this function I'm calling now eval, and I'm passing my entire postfix expression to this. Okay, OP people understood till here? Yeah. Next we'll look into the eval function. See, you're calling eval by passing the entire postfix expression. So the postfix expression gets copied to expr here, and here I have few local declarations. I have character C, int position, float, result, and smax. Okay, so this is the stack. Okay, so this is the result, to hold the result, and float operand 1 and operand 2. So these are required to hold the 2 elements which will be popping from the top of the stack. So the first element that you are going to pop from the stack will be assigned to OP2, and the second element which you are popping from the stack will be assigned to OP1. Okay, and R is another variable. Okay, so which we have taken, and then top initially initialized to 0. I'm starting here. Okay, position is equal to 0, and C of expr of position not equal to null character. Now what this for loop does, it will start scanning all the symbols or tokens from the given postfix expression. from position is equal to 0 to EXPR of position not equal to null character position plus plus. Okay. Next, after you scan the first operand or the first token from the given postfix expression, you got to check whether it is a digit. Okay. So is digit. There is a function with the name is digit, using which you can check whether it is a digit. Similarly, when we were you people understood infix to postfix conversion, okay, so we understood a built-in function called as is alphanumeric, is alpha num, correct, no? Similarly, there is a built-in function with the name is digit, and it tells whether the character which you pass to it is a character or a digit. Okay, if it is a digit, so what is digit will return as true. If true, now what we are doing, we are pushing that onto the stack, and this is the point where you have to understand little more. Observe here. Say for example, I have entered something like this. Let me write here 2, 3 plus. This is my postfix expression. OP people are seeing? Can you see this? What I am writing?
Yes, sir.
Okay, I have written 2, 3 plus. This is my postfix expression. Now initially, what is the symbol you will be reading? 2. I read 2. Okay, and see the EXPR of 0 is how much? 2. That gets assigned to C, and you are checking is digit of C. Okay, now 2, is it a digit? 2 is a digit. What is the condition? Condition is true. Now what you got to do? If it is a digit, you got to push it onto the stack. Yes or no? Now you are calling push function. Push, stack you are passing, top you are passing, and just observe this now. So what this supposed to be? The third argument to push, what it should be? This is stack, this is top, and what are the other thing that is required? Please respond. Yes?
Element to be pushed.
Element to be pushed. But what we have written here, C minus 0. Observe here. Now this 2, 3 plus, where it is stored? It is stored in EXPR. What is the type of EXPR? EXPR is a character array. Now this 2, so we have checked here. Where it is? Yeah. Is digit of C. Okay. Yes, it's a digit, okay, but it is not integer 2. Now is digit of, it is not actually 2 also, it is 50. Hope you are following. See, because I told, I don't know, long back I told you ASCII value of 0 is 48. Okay, when I store this 0 in the form of character, it is not 0, it will take its ASCII value. How much it is?
48.
48. So now this is the 2 which we are reading, but this 2, is it stored as integer or as character? Character. Now for character 0, ASCII value is 48. Now I'll take 1. For 1 how much it is? 49. And for 2 how much it is? 50. Now when you are saying is digit of C here, it is not 2, is digit of 50. Okay, 50, is it a digit? Yes, it's a digit, and the condition is true. You come here, yes, ampersand top. If I write only C here, what get pushed onto the stack? Say for example minus 0, inside the single quote I'll remove, I'll erase, I'll write only C. Now what get pushed onto the stack?
Correct.
50. ASCII value of 2. How much it is? 50. 50 gets pushed onto the stack. But I don't want 50. What I want is 2. Correct, right? Now the C is nothing but how much now? 50. C is nothing but 50 minus, now inside single quote you are written 0. Whenever you write any digit inside a single quote or any character inside a single quote, what it will take is ASCII value of it. Now what is the ASCII value of 0? 48. Now 50 minus 48 is how much?
2.
2. Now my intention was to push what digit onto the stack? 2. And now I got 2. Yes or no? So this is one simple way to convert into integer. This 2 was a character which was internally stored as 50. I don't want it as 50 to be pushed onto the stack. I don't want it to get pushed as 50 into the stack. I want it to get pushed as 2. Now what is that I am doing? Very simple thing. So C is 50 minus, from that I am subtracting the ASCII value of 0. That is 50 minus 48. How much it is? 2. Now what gets pushed onto the stack? It is the integer 2. Is that clear? Yeah. So let me go
Yes, sir.
and scan the next symbol. What is the next symbol? 3. So 3,
3.
what is its ASCII value? Again it is stored in the form of what? Character, because we have declared it as character expr. Yes or no? Now if can I declare it as integer? Integer expr. What will happen if I declare it as integer expr?
We cannot give variables.
No. You cannot read the operators. Plus, minus, because when I say postfix expression, it has operators also. Plus, minus, divide, exponentiation. Yes or no? If you make it as integer expr, so then you cannot read any of the operators. Now I want to read operators also. I want to read what? The digits also. Now one way I can do is by declaring it as character expr. But if I get the characters from the array and if I try to push them as it is onto the stack, it is not the digit or the integer that gets pushed onto the stack, it is its ASCII value, because we have stored it in the form of a character. Okay. So now if I take this next symbol 3, okay, so 3 in character representation, it is 51. So because ASCII value of 3 is 51. Okay. I read it. So is digit of 51? Yes, it's a digit. Now push stack top. Now C is 51 minus ASCII value of 0, that is 48. 51 minus 48. How much it is? How much it is? 3. What is this 3 is? Your integer 3. And this 3 gets pushed onto the stack. Correct? Next. The next symbol which I am scanning is plus. You come here. If is digit of plus, is plus a digit? No. So this you are not pushing on this onto the stack. You will come to the else part here. Now what you will do in the else part, if it is an operator or if it is not a digit, so as per the logic of converting a given postfix expression, evaluating a given postfix expression using stack, so if it is an operator, what do you have to do?
We have to remove elements from the stack and
Perform the operation. Correct, no? You got to remove top 2 elements from the stack. How to remove? You got to call pop. Pop from the stack, correct, no? And the first element which you are popping, where you will assign? To OP2. Correct, right? Operand 2. And the next element which you are popping, you will be assigning it to operand 1. Okay. Then you are making a call to the function OPER and you are passing the character. Now what is there in C? It is the operator now. If it comes to the else part, in C you have the operator stored. C is holding this plus, and what will OP2 be holding? See, 2 gets pushed onto the stack, 3 gets pushed onto the stack, and the next symbol which is scanning is plus. Now since it is an operator, you have to pop the top element from the stack and assign it to OP2. Now what get assigned to OP2? 2 or 3?
3.
3. And then what gets assigned to OP1?
2.
2. So what is this? This is C is plus, and this is 2, and this is 3. You are calling operation. OPER, correct, no? It is nothing but operation. I want to perform this plus operation on OP1 and OP2. OP understood? OPR is nothing but the operation. Okay. Now I want to perform this plus operation on OP1 and OP2. Okay. Now we'll go to the operation OPER function. So here is OPER function. See, I'm copying the operator which is available in C to another variable called as, or formal variable called as SYMB. It gets copied to SYMB. And then the first operand gets copied to OP1 and the second operand also gets copied to OP2. Now switch symbol I have written here. So now what was the operator? Plus. It comes to case plus and return what? OP1 plus OP2. If similarly, if the operator is minus, it will return OP1 minus OP2. If similarly the operator is into, it will return OP1 into OP2. So case divide, if it is a divided by operation, it will return OP1 divided by OP2. And then, so if it is an exponentiation, see what we are doing here? Power of, we are making use of the built-in function power. So because of that POW, we have used math.h. So without including math.h, so it is not possible for you to use POW. Okay, power of OP1 to the power of OP2. Okay, and what we are doing, the result what we get, we are converting it into float. Okay, and then casting it into float. Now case, okay, modulus operator, again what we are doing, so we cast, OP1 is by default, because modulus you cannot find on the floating point operands. Okay, you are casting this OP1 to integer and OP2 is also casted to integer, and you are finding the remainder, and the result you are casting it into float. Okay, basically this OP1 and OP2 are floating point, but on floating points you cannot find the modulus operator, the remainder. So that reason we are casting OP1 and OP2 integer, and after you perform the operation, the result is casted into the float. So if you have entered an operator which is not here, so then it says invalid operation or invalid operator. Okay. Now as usual we have, so this is what the operator is doing. It will find the result and the result is returned. It is returning the result, you can see here. So these are the results that are being returned based on the operator. And the returned result, where it get assigned? To R. Correct, no? The returned result gets assigned to R, and what are you going to do with this result? Push it onto the stack. Okay? Push, yes, ampersand top and R. Here you don't have to do R minus 0, because this result is already in the form of what? Integer. Correct? So sorry, floating point. Here it is in the form of floating point value. All results are floating point value. Okay, they get pushed onto the stack. Push it onto the stack. And you repeat this process. Repeat this process until you finish scanning all the tokens or the symbols from the given postfix expression. The moment the control is out of this for loop, okay, this is the closing for else and this is the closing for the for loop. The moment the control is out of this for loop, now what you are doing, you will pop the data which is available on top of the stack and you are making it as the result. Okay, and that gets returned. Return the result. And this result goes to the main program, and here you are printing. So print, so %f, and the result also, result of the evaluation of the given postfix expression gets printed here in the formula, and we have declared it as result as the float, and hence the format specifier used here is float. OP people understood?
Yes, sir.
Okay. Now let me erase all these things and we'll go for execution, and then we will debug the program. Yes, yes.
Break statement after each case.
One second, I'll clarify on that. Yeah, break is required, but the statements what we have written here is written. Observe here. See, at a time, how many symbols you are passing? Only one symbol. So this symbol can be either plus, minus, into, divide, exponentiation, or modulus. So when it is plus, it comes here, finds the result, and returns from here. And then no question of it continuing with the remaining cases. Yes or no?
Yes, sir.
If return statement is not there, say for example, I am writing a switch case and I am not writing return statement inside the case, then break is required. Got my point?
Understood, sir.
Yeah. What happens here? When it comes to case 1, it will find the result and it will return from the here. So it will go back. Go back to where? So go back to the statement which is following this OPER, from where this OPER was called. And it will never come to this. And it will not come to this. Yes or no? No. Now what is the statement that is following the call to OPER? OPER was called from here. It assigns the return value to R, and this is what it executes next. Okay. Hope you understood this. So now I'll save my program. So we'll go for executing. So I have written few examples in a sheet of paper. I'll just get them. Okay, I'm back. So I have the example. We'll take the same example and we'll also do the tracing. So first I'll execute and then we will trace or debug the program. Okay, I'm running the program now. Okay, enter the postfix expression. Let me enter the very basic postfix expression 2 3 plus. Okay, execute it, Alt F5. So the original postfix expression is 2 3 plus and the result is 5.0. Okay, since the result we have made it as floating point, at 5.000 you are getting. You have to make it as floating point itself. Okay, I'll run again. So 2 3 star. Simple examples I'm doing. 2 into 3 6. Again control F9. 6 2 divided by. So 3. Again I'll do control F9. Simple expressions I'm entering. 6 2. Now I'll enter modulus. Alt F5. So 0. Okay, because it gives as reminder 6 by 2. When you do the modulus operation, what is the reminder you get? 0. Okay, I'll take a different thing. So control F9. So now what I'll enter is, so 5 2 modulus. You to get the remainder as 1. So remainder is 1. Okay. And then exponentiation 1 we will do. 2 2 and then exponentiation caret symbol. So 2 to the power 2, it is 4. Okay. Now let me add clear screen. So clear screen. So now I'll compile. enter the postfix expression. I'll enter this expression now. 2, 6, 2, so divided by 3 minus 4, 2 into plus. This is what I have entered. Alt F5, and the result of this expression is 8. So now one more example. 4, 6 plus 3 minus 7 is the answer for this. Okay, and we also solved a few examples. Okay, can anyone open and tell me one postfix expression which we solved? Same thing I'll give as input. I want one of you to tell it, because I think we have solved two. We have converted two postfix expression, evaluated two postfix expression, so complex expression. So just tell that expression, I'll input the same. Yeah, the slides with you. People have slides with you, no? Yeah, can anyone tell? 2, 3 power okay, 4 star 2 minus 5 1 divided by 6. That's all. Divided by plus 4. That's all. Okay. So result of this is 4. Is it correct? So because I think we have solved it. Have we solved it or not?
There's another plus at the end.
There is one more plus at the end?
Yes, sir.
Okay, let me add it. Okay, let me give it again. 2, 3 exponentiation 4 star 2 minus 5 1 divided by 6 divided by, after this divided by there is plus, no? Is there a plus after this?
Yes, sir.
Plus 4, and you are saying there is one more plus.
Yes.
Yeah. So answer is 34.83.
Yes, sir.
Okay. So earlier we did it as integer, correct? Now since we have declared it as floating point, 34.83. So this is the correct answer. Okay. So 34.833. Okay, done. Now the other one, I think we have solved one more. Can I have that?
Uh, 6 2
6 2
divided by 3
divided by 3
minus 4 2
minus 4 2
star plus.
star plus. That's all?
Yes, sir, that's all.
Yeah, this we did now. This is the one which I executed earlier. Okay, it's the same program. Answer you'll get it as 8.
Yes, sir.
Alt F5. The same thing which we did. Okay, no issues. Okay, now we will go for tracing the program. So with the watch window, So I'll add in the watch window, we'll add the expr, we will add, and then expr of position we will add, expr of position, and then we will also add this C. Okay, we'll add C, and then we'll add the stack yes, so we'll add the stack yes, and then what else we'll add, op1 and op2. Top also we will add, top, op1. So let me add op2 first. Now op2, and then R, because R represents the result. So this R, local variable, oh sorry, R and result. So the final result, this one. Okay, now we'll start debugging. I'm going with F7. Enter the postfix expression. So I'm dating. So I'll take this 6 2 divided by 3 minus 4 2 into plus. Okay, this is the expression which I'm reading. So please make a note of this. Take a piece of paper, pen, and please make a note of this expression. Okay. Hope all of you noted. 6 2 divided by 3 minus 4 2 into plus.
Yes, sir.
Okay. Now I'm printing the original postfix expression as it is. Alt F5, you can see the original postfix expression is this. I'm printing it as it is. So now I'm making a call to eval by passing. I'm passing this entire postfix expression as argument to it. Now, so top, I'm initializing it to -1. Now position, I'm starting from 0. You can see here, okay. So position is 0, okay. Now see, C is written in single quote. See, if C, this 6 is written in single quote. What does it mean? It is not a digit 6. It is inside the single quote, means it will take its ASCII value. It is a character right now. Okay, so that is the reason it is inside the single quote. So if single quotes are not there, then you can say it's a digit 6 or integer 6. Now don't confuse, integer 6. Now is digit of C. You are checking whether 6 is a digit. Yes, it is a digit. F7. So don't confuse with the digit and integer. This is not an integer right now. It's a character. Okay, but 6 is a digit. So since the condition is true, we are here. Okay, so push to the stack this one. Okay, now this C inside the single quote 6 it is, its ASCII value is 48 is 0, it is 48, and for 6 it is how much? 54.
54.
54 minus 48. How much it is? 6.
6.
So now we are calling push. Now 6.0 gets pushed onto the stack. Where is the stack? Here. Okay, you just observe now. Okay, I have to go back and I can just observe here. Say 6.0 got pushed onto the stack. Done. Next, the next symbol which you are scanning is 2, character 2. This 2. Is it a digit? Yes, it's a digit. And again, 50 minus 48. Okay, you're pushing it onto the stack. It is 2.0. So 2 point. So it has pushed to 0. I don't know what happened. It should be 2.0. Oh, 1 second. Let me check. I don't know what I have given while writing. Alt F5. I've given it 2 only. -50 minus 48, 2.0. One second, let me check. Next is not a digit. You're popping to OP2, so 0, it will get 0, 0. Okay, OP2 is 0.0 and OP1 I have not added. Instead of OP1 I have added OP2 itself 2 times. Okay, so 1 second, let me do Control F9 again. So this OP2 2 times I have added. Let me remove this. And add OP1. Okay. 6, 2 divided by 3 minus 4, 3 minus 4, 2 into plus. So reading the first number, it's a digit, so it is 54 minus 0. So 6.0 got pushed onto the stack. Now the next symbol that is scanned is 2, character 2. Okay, so it is 50 minus 0. Yeah, now I think earlier we went wrong somewhere. So now 2.0. Can you people see this?
Yes, sir.
Yes, sir.
So 2.0 got pushed onto the stack. Now next I'm checking, next symbol that is being scanned is what? Divided by. Is it a digit? No, it's not a digit. Now it will go to the else part. Now pop the top of the stack. What is there on top of the stack now? The symbol scanned is divided by. It is not a digit. Now you are popping the top of the stack 2.0 and assigning it to what? OP2. So this OP2 will become 2.0 now. So OP2 is, I'll go back. OP2 is 2.0. Now we are popping the second element also, that is 6.0. and assigning it to OP1. Next we are calling operation. We are passing C, that is divided by, we are passing 6 and we are passing 2. Now what is the symbol now? It is divided by. So case divided by. Now return the result OP1 by OP2. OP1 is 6 and OP2 is 2. 6 by 2. So how much it is? 3. So it will return, R will become 3 now. So result is it was wrong. How can it be 6? 6 by 2. So 6 is pushed. Sorry, I don't know what key I am pressing instead of F7. Let me do it from the beginning. Sorry. 6 2 divided by 3 minus 4 2 into plus. So I'll be careful now. So all this is fine. Now 6.0 gets pushed onto the stack. 6.0 is pushed. Now it's still in the pop. Okay, symbol is divide. 6 by 2, answer is 3. Return the result. Yeah, now it is 3. I don't know what I did earlier. Okay, now it is 3, correct. And so instead of F7, I think I pressed the key 7 or F8, I don't remember. Okay, is it clear now?
Yes, sir.
R is the result. It is 3.0. Earlier it was showing 6.0 because I think I pressed wrong key from the keyboard. Now, so and what we do with this, we push this onto the stack again. Okay, so it is 3.0 is pushed onto the stack because this was the top was -1, now it become 0. Okay, next you are scanning the next symbol 3 and you are checking whether it is a digit. Yes, 3 is a digit. Now it is 51 minus 0, that is 3. So 3.0 gets pushed onto the stack. See, there is one more 3.0 pushed onto the stack. Next symbol what you are scanning is minus. So minus is not a digit. Now you got to pop 2 elements. So first 3.0, this 3.0 is popped and gets assigned to OP2. Okay, so OP2 is 3.0 and OP1 also gets this 3.0, another 3.0. Now top is 0, that means it is pointing this is the only element which is there on top of the stack right now. So top is pointing to this and these are not accessible. Okay, so OP1 is also 3.0. Now you are calling operation minus 3.0 3.0. So goes to case minus 3.0 minus 3.0. What the result it returns? It returns the result 0. R becomes 0 now. R is 0.0. Now push this result again back to the stack. Now the stack is 0.0. Okay. So now this is the only element on the stack because top value is 0. That means you can access only till here and these are not accessible. Now again continuing with the scan. So the next symbol which you are scanning is 4. Is 4 a digit? Yes. Now 52 minus 0, that is 52 minus 48. So 4.0. gets pushed onto the stack. See, 4.0 is pushed onto the stack. Next, symbol that you are scanning is 2. 2 is also a digit. Now it is 50 minus 48. 2.0 gets pushed onto the stack. So 2.0 got pushed onto the stack. Next symbol which you are scanning is into. Into is not a digit. Pop 2.0 and assign it to OP2. See, OP2 got 2.0. Pop next 4.0 and assign it to OP1. See, 4.0 is popped and assigned to OP1. Now you are calling the operator. Operator is into, or the operation is into 2.0 and 4. This is 4.0 and this is 2.0. 4 into 2, what you are doing? So the symbol is into, goes to case into. Now OP1 into OP2. What returns now? 8 it returns. Result is 16 it is showing. Okay, I think I pressed F6 again instead of F7. No issues. You people understood, I think. So it got pushed the 16. Now 16 minus 0, it will say, so the next operator is plus. So 16 plus 0, it will say 16 is the answer. Okay, now return result. So result is 16, but it is not the correct result. Alt F5 I am pressing, so not even 16 also, because I pressed something. Instead of F7 I pressed F6, I think. Sorry. So let me run now. OP people understood how to trace it? Yes or no?
Yes, sir, understood.
Yeah, I'll press Control F9 and let me run it again, just to show you, because it showed you the wrong answer because of me pressing the wrong key from the keyboard. Okay, 6 2 divided by 3 minus 4 2 into plus Alt F5. Oh, I don't know, some issues are there, I think. Control 6 2 3 minus 4 2 into plus. Now it is correct. Sorry, I don't know what I missed previous execution. 8.0 is the correct answer. You are getting it. Anything to ask? You understood now the overall logic?
Yes, sir.
And this is not required, this line. So you can also read it by using fgetS. Okay, that is not required. So this is the program, and even this program also I'll upload it to my Google site. Copy this, and you can execute this program for the next week. Okay, from Monday onwards. So next week I'll give you the tar of an eye program. Again, that is again a small program, tar of an eye program, and this is also a small program, and you can easily remember this. A very simple logic for this. Hence, they combined these two programs into one lab program. Okay. So this is 5a.c. Save it as 5a.c. So 5a.c. The other one we will save it as 5b.c. So any doubts you can ask me.
Sir, when we pop out an element from the stack, it should be deleted, no, sir?
No, that's what I'm mentioning.
Sir, but in watch window it was showing like that only, sir.
What it was showing?
Sir, when we popped out an element from the stack, sir, it was again shown in the watch window, sir.
Yeah, watch window, it shows. See, basically when you are popping, it will not be removed from the stack. It will not be removed from the memory. See, what happens is, you just decrement the top value. You read that current element which is there on top, and then you will decrement the top. Top gets decremented by 1, and it is pointing to the next element which is there on the stack. Understood?
Yes, sir. Understood. Okay, sir.
Top is pointing to the next one. That means now the top, earlier top was 5. Now after popping, what will do? We will read that element which is at index 5 and will decrease the top. Top is 4. Top becomes 4, and that 5 is still there in the memory. Understood?
Yes, sir. Understood, sir.
What will happen? So since top is already 4, you cannot access that fifth element. Now, what is the next operation that you can do to that memory location? If you do one more push operation, top gets incremented and that location gets overwritten.
Oh, okay, sir.
Understood, no?
Yes, sir. Understood, sir.
So it is with this analogy. So pop is nothing but decreasing the top by 1. The content in the memory will be there as it is, and next time when you are pushing beyond the index 4, it gets overwritten. But till that time it will be there in the memory.
Yes, sir. Understood.
Okay. It's something like even in our natural life also it's the same thing. See, you have stored something in your hard disk, okay? So you don't have to erase it. See, for erasing you have to spend extra clock cycles. What you do is, see, you have stored something on the hard disk, you just disconnect the pointer to it. Understood? See, when you store something, you require a pointer to access it. You should know where it is stored. Correct? No? If I just erase that, the connection is gone. You have something stored there, and the connection is gone. And next time, so I want to store something. So the memory, once the connection is gone, say I had stored 500 MB of data someplace, and I add a pointer. As long as I have the valid pointer, so that memory is accounted. The moment the pointer is deleted, okay, the content will be there. And what will do, and that memory will be added to the free space, but it is not actually free. It gets added to the free space, and when I am storing the data, so that space will be used, and it overwrite happens. And you have observed this thing, disk recovery. Say for example something happens to your system, and what you will do, you will go for recover.
Yes, sir.
If the memory location to which the pointer is lost and which you disconnected, and if the data is still there, and if it is not yet overwritten by some other data, so still they'll recover it and they'll give you.
Yes, sir.
There is, I think you can try, there is a software called as disk drill. Say you delete something, using that disk drill software, if that data which you say deleted, if it is not overwritten by some other data, so you can still access that by using disk drill software. I don't know whether you have the knowledge of Unix operating system. There is something called as inodes. Say for example, in Unix operating system or Linux operating system, I have created a file and I delete it. Okay, but and every file will be given a unique number called as inode number. Okay, file names are for us, okay, because we cannot remember so many numbers to remember all the files. So we remember the files by their names, but operating system will remember the files by using the inode numbers. Okay, so when I am saying deleting a file from the Unix operating system or the Linux operating system, just erasing this file name, that's all, but the content will be there still in the hard disk until it is overwritten by some other file. So if you know the inode number, you can still access that file.
Okay, sir.
No. Here, when I store something, to a variable, it will not get stored into the hard disk. It will be there in the RAM. Okay, a read-only memory. So we're not storing anything into the hard disk here. So we were playing inside the RAM now. Yeah. Okay. Now I think we'll stop here, and tomorrow I think we got to do. Since I've already completed the Tara Funai problem, only thing is the lab program is left on that. So tomorrow we'll continue with Ackerman function, and soon I complete that, we can get into the queues. We'll start the queues. Am I audible?
Yes, sir.
Okay. So my system is saying Microsoft Teams is not responding. Okay, I think I'll disconnect soon. So we'll end the meeting here, and we will join again. I think I have to download the attendance also. I don't know whether it will allow me to download or not. So just be there, don't disconnect. So if possible, I'll download the attendance list. I think if you have class from 4 to 5, you can leave, because I think anyhow it will show me joined and left. I'll download because I'll be there in the meeting. So once this recovers, okay, I'll download. So thank you all. You people can leave now. So because even after you leave, I can download the attendance list. Okay, thank you.